Hi, my name is Jennifer Kemp. I'll be presenting my industry research unit topic today, the application of FWD data as a diagnostic tool for rehabilitation design in Australia. I'd like to give a little bit of background about myself. I've been working as a pavement engineer for 7 years. I was initially involved in pavement condition testing and rehabilitation design with a small consultancy. It was at this time that I developed my passion for pavement rehabilitation and condition assessment. I now work in a larger consultancy where the majority of my projects are new pavement designs, and occasionally I get to do some pavement condition assessment and rehabilitation work. Before I move into the body of the presentation, I would like to provide an overview of what will be discussed today. In the introduction, I will discuss the importance of condition assessment of pavement and what the research objectives are. I will then cover the main points noted in the literature review and include a brief overview of the methodology that was adopted in the study. This will be followed by the analysis of one case study, Donaldson Road and Rocklear, to demonstrate how the additional deflection bowl parameters are applied. The final section of the presentation will include the conclusions from the study, the limitations, and recommendations for future work. Australia's road network makes a crucial contribution to the economic development and growth of the country. In addition to this, the road network provides access to employment, social, health, and education services. Roads open up areas and stimulate economic and social development. For these reasons, road infrastructure is considered one of the most important public assets. As can be seen in the figure provided, Australia's cities are connected by a large network of roads which measured over 800,000 kilometres in 2018. In the 2016-2017 financial year, all levels of Australian government combined spent $26.1 billion on the construction and maintenance of roads. Now, due to this expenditure, it's important that as a part of the road network development, we give consideration to the maintenance requirements of existing roads. If we look at the graph depicting typical pavement condition deterioration with time, it can be observed that without scheduled maintenance, the pavement life can be severely impacted. If insufficient maintenance is carried out, roads may need reconstruction or major repairs just after a few years. That deterioration spreads across a road network very quickly, resulting in soaring costs and has major financial impacts on the economy and citizens. Hence, it is important that good asset management practices be in place for the road networks. As we move away from the construction of new roads towards the preservation of existing ones, the need for good and easy to use pavement condition assessment tools arises. Current Australian pavement evaluation procedures do not use the full extent of the information available from deflection bowls. It is with this in mind that the following research objectives were set for the study: to identify how FWD deflection bowl parameters are used and which are most applicable to Australia, to provide preliminary structural condition thresholds for typical Australian pavement types, to use the selected parameters and identify condition levels on 3 different projects in Australia. Note that this was carried out as a network level assessment, so it does not include a high level of detail. The final objective was to identify additional work that was to be carried out to improve network assessment of the structural condition of pavements. The topic literature review first discussed the Australian rehabilitation procedures and then looked into the international approach to pavement condition assessment. The Ausroads Guide to Pavement Technology Part 5, Pavement Evaluation and Treatment Design, considers pavement condition to have 2 aspects. It has a functional, the level of service which is provided by the pavement to the user, referred to as serviceability, and this is often measured by roughness, which is the ride quality, and the structural aspect, which is the pavement's load carrying capacity. It is the structural aspect that we are focusing on. So structural capacity is measured by service deflection. Now, there are several devices that can be used for measuring deflection, and they fall into two categories, one being falling loads, which is covered by FWD and heavyweight falling deflectometer, and by rolling loads, which is the Benchmark beam, the traffic speed deflectometer, and the deflectograph. Structural condition is assessed using the following deflection bulb parameters. The maximum deflection, which is the peak deflection where the load is dropped, the curvature function, the deflection ratio, and the subgrade response. Now, as can be seen in the graph, these parameters use a very limited amount of information from the deflection bulb. The question arises, is there a reason to use more deflection bulb parameters? The risk with using only the maximum deflection to assess the pavement's overall structural capacity is that it is possible to have identical maximum deflections for pavements at different structural capacity, as shown in the figure presented in this slide. Several deflection bulb parameters have been developed internationally to define the structural condition of individual layers of pavement. The first set was developed in South Africa and the second set in the United States. For the presentation, we will review the South Australian parameters as these were adopted in the case study discussed in the next section. Horak, a researcher in South Africa, proposed the use of additional parameters in his thesis as a way to identify and pinpoint structural deficiencies. He noted that out of the parameters available, the base layer index, middle layer index, and lower layer index were found to correlate strongly with pavement structural condition and individual pavement layer associations. The table and figure provided in this slide summarize the various deflection bulb parameters and their association with the various structural layers. A table of the condition thresholds for thin asphalt on granular base has been provided as an example to the threshold levels adopted in South Africa. So, in summary, the literature review showed that only a small part of the FWD deflection bulb is currently considered in the pavement condition assessment in Australia. It was also noted that some structures may have the same maximum deflection, with some layers not being in good condition. The maximum deflection alone is insufficient to characterize the condition of the full pavement structure, and that international deflection bulb parameters can be used to enhance network pavement condition assessment. In order to determine the suitability of adopting additional deflection bulb parameters in Australia, 3 case studies were analysed in detail in the thesis. For this presentation, we will focus on one case, Donaldson Road in Rocklear. The data used in the research was provided by Brisbane City Council and converted from 50 kilonewtons to 40 kilonewtons. A desktop visual condition assessment was carried out to correlate visual defects with the assessed structural condition. For each of the 3 case studies, the difference in the condition assessed between the Australian parameters and the international parameters has been compared, including a discussion on how the rehabilitation strategies differ. The 3 case studies that were examined in detail were selected due to the different pavement types that they represented. We had thin asphalt over granular, which was Donaldson Road, thick asphalt over granular at Tennyson Memorial Avenue, and also asphalt over a cement-treated base, Hague Road. The selected deflection bulb parameters for the analysis are as shown in this slide, and they include the base layer index, the radius of curvature for South Africa, the middle layer index, the lower layer index, and the Australian parameters of the curvature function, the subgrade response, and the deflection ratio. Now onto the case study analysis. Donaldson Road in Rocklear is part of a freight route in the Brisbane City Council area. The pavement type that was identified on this road is a thin asphalt over a granular base. Now, the graphs shown on this slide are the cumulative sum control charts of the outer and inner wheel path. And the image is a plan view of Donaldson Road showing the maximum deflection changing colour with the changing condition. Now, the maximum deflection along the outer wheel path is noted to have high variability. The chart here shows that over the 320 metres of pavement, there are 4 sections, with the most distinct section at chainage 275 to 355 shown as poor condition. It's interesting to note that the poor condition coincides with the area of pavement that does not have a shoulder or curb, indicating that there is possibly some moisture ingress at that point. The outliers seen at chainage 315 to 320, where the maximum deflection is rated as good to warning, can be attributed to the fact that there is a driveway present at that location. It can be inferred that it's likely that moisture ingress at the edge of the pavement has been prevented due to that driveway. Now, the inner wheel path has a lower variability with 3 distinct sections shown in the chart. The section at chainage 280 to 350 is also shown as poor condition, which indicates that there may be a need of reconstruction somewhere in the near future to restore the pavement strength at that point. From chainage 355 to 430, the condition shifts to warning with some good sections. This occurs in both wheel paths. This is attributed to the unsealed shoulder sloping away from the pavement, which has prevented ponding of the water at the edge of the asphalt. The remainder of the tested pavement has a highly variable maximum deflection. Now, when looking at the tabulated values, the deflection ratio and the curvature function do not flag any pavement structural issues. When examining the additional parameters presented in this table, the condition of the subgrade is flagged as warning to poor for the whole section by the lower layer index. Similarly, the majority of the subbase is found to be also in a warning to poor condition. This is shown by the middle layer index. But then in contrast, we have the base layer index showing only partially in warning to poor condition, with the radius of curvature mostly in good condition, indicating that the base and surfacing are still performing satisfactorily. When I reviewed the Google Street View from 2015, no defects were visible on the surfacing. This correlates quite well with the radius of curvature results. Considering that the poor subgrade rating coincides with the section of pavement that has no shoulder or curb, it is likely that the pavement is deteriorating due to moisture ingress from the edge of the pavement. When we compare the rehabilitation that would be carried out from the maximum deflection alone, it can be seen that chainage 215 to 270 and chainage 360 to 430 might not have been flagged as a concern. Now, if the BLI, MLI, LLI, and the radius of curvature are used, the rehabilitation strategy would be focused on improving the subgrade and ensuring that there is no water ingress from the edge of the pavement. So the case studies demonstrated that it is possible to pinpoint and identify structural deficiencies in various layers and locations when the additional deflection bulb parameters are adopted. This would not have been possible with only maximum deflection, the curvature function, and deflection ratio. However, it was noted that in some cases, not the Donaldson Road case, the visual condition of the surfacing did not correlate with the rating from the deflection parameter, radius of curvature, and the BLI associated with the surfacing and the base, respectively. It is likely that the lack of correlation between the radius of curvature and the BLI is due to the fact that the threshold values were not tailored to Australian pavement types and conditions. This is something that should be looked into in future research. So in conclusion, the parameters adopted in Australia are the maximum deflection, the curvature function, deflection ratio, and subgrade response. Through the case study analysis, it was demonstrated that it is possible to pinpoint and identify structural deficiencies in various pavement layers and locations. It was also demonstrated that surface distresses can be directly linked to the structural condition of individual pavement layers using the additional deflection bolt parameters identified in the literature review. It is important to note that there were some limitations of the research that was carried out. One of them was that the temperature impact on materials was not considered in the research, although it's noted that where we had the thicker asphalt, the temperature was close to the average working temperature. It's also noted that the international condition thresholds were adopted, which don't necessarily indicate the same level of deterioration of an Australian pavement. I would like to also note that at the start of the research project, one of the objectives was to propose condition indicator thresholds to adopt for Australian pavement types. It was recognised that this was not possible in the project timeframe. As a result, only the international thresholds have been used in the assessment. So moving on to some recommendations for future research, I'd like to say that one of the main things identified is the need for a parametric study that would consist of varying the strength of each layer and assessing which deflection bolt parameter is affected. This would provide some insight into which layer relates to which parameters. Also, further research into the thresholds to be adopted for the indication of condition for the different pavement types is required. The future research efforts into this area should also consider non-linear behaviours of the individual pavement layers. This is something that I was unable to incorporate into this research. Now, I'd like to thank you all for listening, and please contact me if you have any questions. My contact details are as per the second slide of this presentation. Thank you.